this right now. And our next one is going to be, I'm going to do number 22. I did number 21 in class, but this is about the work problem. Work. And when you read it, you'll be reminded of it. Oh, I gotta type that up again. Hold on. Okay, that's better. And here's that work problem. When I think of work problems, I think of our format, our formula for it, which is, let's see, an experienced bricklayer constructs a small wall in 3 hours. The apprentice completes the job in 6 hours. Find how long it takes if they work together to complete the wall. Alright, so the simple setup here is 1 over 3 plus 1 over 6 equals 1 over x. Okay, and there it is. So I'm going to get my denominators the same, right? So let's see, if this is a 3, then I'm missing the 6 and the x. So that means I got to multiply top and bottom by 6x. The 1 6 I'm going to multiply by, what do you think I need here? 3x. Give me 18. And the last one here, just the x, I'm going to multiply by 18. 18 over 18, right? That way I've got 18. We did this in class, and why am I using 18 when I could have used 6? Alright, it really doesn't matter though, does it? And watch. So this will give me a chance to show you that. Okay, so my denominators are the same, so I'll multiply my numerators out. So it's going to be 6x times 1, 6x, plus, what do I got here? 1 times 3x is 3x, and that's going to equal 18 times 1, which is 18. This is where we end up here. So I got 6x and 3x is 9x. That equals 18. X equals 2. So if they work together, it'll take them 2 hours. Okay? I'm just noticing something here that we could do. No, I'll leave it at that. I don't want to change our subject here. Alright, so there we go. We've got it this way. Okie doke. And let's move on to the next one. Alright, here's number 51 of our homework set, 7.6. So it says, one custodian cleans a suite of offices in 3 hours. When a second worker is asked to join the regular custodian, the job takes only 1.5 hours. How long does it take the second worker to do the same job alone? Oh, here's a little twist to the problem. So now they're telling us to solve for the second worker in our scheme of things, and they're telling us what the job took for them both to do. Alright, so that means that we've got a different variable to solve for. So let's see, so one custodian cleans a suite of offices in 3 hours, so that's going to be 1 over 3, plus, when the second worker is asked to join the regular custodian, the job takes only 1.5 hours. So that means something is going to equal 1 over 1.5, I'll say, or 3 over 2 if you want to work with fractions, which I doubt. Okay, so now we've got to figure out what is the how long it takes for the second worker to do the job alone. All right, so that's going to be 1 over x. That's what we're going to solve for. So you see, there's a little different flavor of this problem going on. And I suppose I could do it the same way that I've been doing. And I will say, let's try it. Let's give it a whirl here. So that means to get our denominators the same, what's our LCD going to be? Here I got 3x and 1.5. Well, I can multiply the 2 times the 1.5 to give me 3. So that means our LCD is going to be 3x. So this one, yeah, so this one will need, to get all three of these the same, I'll have to multiply this one by x over x. This one here, the middle one, I'm going to have to multiply by 3 over 3. Okay, that's working for us so far. And finally, this one, I'm going to have to multiply top and bottom by, what do you think? 2x over 2x. Wow, super. Okay, my denominators are the same now. They're all 3 x's. And now I'll figure out what my numerators are. So here I got x times 1 is just x, plus 1 times 3 is 3, equals 1 times 2x is 2x. Alright, so I got 2x, x plus 3, and equals 2x. So that means I'm solving for x now. So let's see, I'm going to subtract x, it looks like. And I've got x equals 3. And therefore it took the second worker 3 hours to do the job alone if he were working on it alone. Okay, so that means, well, and let's check that then. So that would be what? 1/3 plus 1/3 equals 1 over, well, look, for this sake here, I'm going to write it as 3 over 2. Let's see if we can make that work. All right, but what's 1 over 3 over 2 if we're doing complex fractions? That's the same as 2/3, right? It would be 1 over 1 divided by 3 over 2. Complex fraction, right? Keep, change, flip. So if I flip this, this would be 2 over 3 times 1 over 1, and this would be gone. So this would end up being 2/3. And that's what I'm looking for here. And let's see if we get it. So I got 1/3 plus 1/3. 1/3 plus 1/3 equals, I got 3 times 3 is 9. 3 times 1 is 3. Plus 3 times 1 is 3. 3 plus 3 is 6. 6 over 3 is the equivalent of, if I simplify that, 3 goes into both of these. 3 goes into 6 twice. 3 goes into 9 3 times. So there's our 2/3. So that was correct. Even though yeah, that was pretty cool. A different problem this way, solving for one of the workers. Took that worker 3 hours to, or doing 1/3 of a job in 1 hour, I should say. Alright, that's how you do that. Very good. Next problem. Okay, here's one we did in class about the distance problems. And let's remind ourselves how to do these. This was number 25. Kind of bouncing around here in this section with homework problems. But a jogger begins her workout by jogging to the park, a distance of 12 miles. She then jogs home at the same speed but along a different route. This return trip is 18 miles and her time is 1 hour longer. Find her jogging speed. Okay, so remember when we're dealing with distance that that the distance equals the rate times the time. Time is in hours. Alright, and we'll fill in this chart best we can. And also note to help you when they're, what are we looking for here? It says find her jogging speed, so that means I want to find what R is. And when we do these, it's going to be, you know, I could get, there's two distances here, right? So I could say one distance, let me do it this way instead of rewriting it. So I could say one of the distance was 12 miles, okay, and that rate would be, well, one of these rates has to be, I'm sorry, the time that they give us is x and the other is x plus something. So you can, as we read this a second time, we come upon this to say the return trip is 18 miles and her time is 1 hour longer. 1 hour longer than what? So we could say the time here for the 12-mile run would be just t. We don't know what the time is, but we could surmise that the time for the 18-mile trip was 1 hour longer, so we could say that's going to be t plus 1. So it's easy to see when something is 2 hours longer, or 3 hours longer, or 1 hour longer, that it's 1 hour longer than what? So it's going to be 1 hour longer than the single variable that's in the other equation. Okay, so this time is t plus 1. We're going to multiply this by the rate. We don't know what the rate is. That's what we're solving for, actually. Okay, so I'll just put an R here for now. And this one is equal to 18. Okay, so now if I'm solving for the rate for both of these equations, okay, to solve this, I'll get the R by itself here. I'd have to divide both sides by t. So for this first one here, it would be 12 equals, 12 over t equals the R. Capital R. Should use lowercase r, but I get a habit of using capital R's. Means the same thing. Okay, so that's for the 12-mile run. The 18-mile run, if I divide both sides by t plus 1, then t plus 1, because this is multiplied together, then I see I got t plus 1 as such. So this is going to be 18 over t plus 1 equals r for this bottom equation. So you can see they're both equal to r. So I could think of this now as the substitution method. I could use the substitution method to solve this equation, then use proportions. So if r equals 18 over 21, I can substitute it for this r here, this r. Okay, and so let's do that. So I'll just rewrite it over here. It'll be 12 over t, that equals 18 over t plus 1, because they both equal r. And then I'll solve for t. So let's see, I'll cross multiplying here. I got 12t plus 12. Okay, that equals t times 18, which is 18t. And then let's solve for t. So you subtract 12t. T equals 12, and then t is going to equal 2. Okay, so if t equals 2, are we determining what the jogging speed is? What's the jogging speed? So I guess I got to substitute t in for these equations here. I could put it right here. I could use it here. This t I could substitute it in here for, put 2 in for t, and then I got 12 divided by 2 is 6. So the rate is 6 for this 12-mile run, or jog. And then if I substitute t for the 18-mile run, that would be 2 plus 1 is 3. 18 divided by 3 is 6 as well. So her jogging speed then equals 6. The rate is 6. Not 2. Okay? Good. Alright, here we are moving along. This is number 47. This is a little toughy if you don't remember beginning algebra when we had the motion problems. That's what these are, motion, because it has something to do with the still, like the water, the still water, the still air. We've got wind that is going with the wind behind him, and when wind is against you. So we have the speed of the wind in this case, and when we're on the water, it's the speed of the water, it's the speed of the current. So this all involves motion problems. So we've got a setup here that's really, once we get the setup down, it's really not bad figuring these problems out. Alright, so it is, what do we got? We still have the distance that equals the rate times the time. Let me spread that out. I'll use lowercase r this time. Alright, and so the distance will be the distance, whatever they give you. Now the rate is what is different here. And like in beginning algebra, for the motion problems, we had one rate expressed as x plus y. That's a rate. And we'd use the plus y for things that are going with the current or with the wind, whatever that amount would be. What is the rate of the current, in other words? So the rate of the water or the wind will be y, and the stillness, the rate in the still water would be the x. And that's what they give us in this problem by my little capitalization of still. Okay, excuse me, I got something in my throat. Alright, the time is the time, so that stays the same. And so what do we got here? We've got a boater and, what is this about? A boater travels 16 miles per hour on the water on a still day. During one particularly windy day, he finds that he travels 48 miles with the wind behind him in the same amount of time that he travels 16 miles into the wind. Find the rate of the wind. Alright, so that's what we'll do. So let's put these little clues together. Alright, so we've got our comparisons here of going, one of them is with the wind. I'll just label it with the wind, and the other is going to be against the wind. Okay, with the wind, against the wind. So with the wind, let's look at this again, and we'll get all our details here. So one moment, please. I'm going to get rid of that x plus y for a minute. Okay, back again. I had a phone call, sorry. And let's see, so where was I? Okay, so I got with the wind, and so a boater travels 16 miles per hour on the water on a still day. Alright, so the stillness on the still day traveling 16 miles, that's going to be where the x was in that formula for distance equals x plus y, the rate times the time. I'll just put it like this, times the time. Okay, so that's going to be the x, so it's going to be, the rate will be 16, and since it's with the wind, it's going to be plus y. And that'll be the rate of the wind, the y is. Okay, and that will be the distance that he traveled. During one particularly windy day, he finds that he travels 48 miles with the wind behind him. Okay, so that's going to be 48. So the distance is 48 equals 16 plus y times the time. Times the time. Okay? And then it goes on to say he finds that he travels 48 miles with the wind behind him in the same amount of time. In the same amount of time. So that's going to tell us that we're going to put these two equations equal to each other based on the time. So we'll say that time equals what? We'll solve for t. Alright, when we get to that, I'll show you. So the equal time that he travels 16 miles into the wind. Alright, so against the wind he's traveling 16 miles. The water is still at 16, but my subtraction, my negative is going to be here. The negative represents the resistance, the negative going against the wind, times t. Okay, and there we have it. You can see there's really not much to these equations, really three components. One of them's left for us to solve for. So if I'm solving for time here, remember this is distance equals rate times time. So if I'm solving for time, I'm going to divide both sides here by r. So therefore t equals d divided by r. So d divided by r, I could look at it here as well. So that's going to be the first equation here I'll bring down with the wind is going to be what? 48 divided by 16 plus y. Because that's what r is. And then that's going to be equal to the against, I'll do it. Against is going to be, what is it going to be? It's going to be 16 divided by 16 minus y. And there's our proportions that we have to solve for y. Madness. Alright, so I left my calculator downstairs. Let's see if I can handle this. So I've got, let's see, I got to cross multiply here. So let me do this first, this 16 times 16 plus y. Alright, so that's going to be 16 times 16, I don't know what that is, 16 times 16 plus 16y. Okay? Well, you got a calculator? You know what? I got to do this. I got to figure it out so we're doing it right. Okay, I'll be right back. Okay, let's see if I got this. This is 16 times 16 plus y going this way, right? So that'll give me 16. I'm using distributive property, 16 plus y. And that's going to give me, oh no, that's going to be equal to, I'm not going to do that multiplication after all. That's going to be equal to, okay, and then that's going to be equal to 48 times 16 minus y. So that'll be 48 times, what did I say was 16 minus y. And let's see what we've got here. So let's see, I can divide the 16s out, multiply both, or divide both sides by 16. Notice I'm going to a factor here, so it's okay. So I'm left with this is 16 plus y. That equals, let's see, 48 divided by 16 is 3. So that gives me 3 times 16, which is 30/48, minus 3 times y. Okay, that's looking good here. So how about I got y's on both sides, so I'm going to add 3y to both sides. 3y. And let me scoot this up a little bit. So what have I got? 16 plus 4y equals 48. And now we'll subtract 16 from both sides. And I've got 4y equals, what is that, 2 and 3, 32. Divide both sides by 4. So y equals 8. And y is the rate of the wind. So we've got it. That's it. Crazy, but we did it. You can go over that math the way what I did there. Watch this video over again and a couple times. I may I'm not going to comment on anything on the test or anything like that now. All right, so let's see, that's that, and we'll move on to the next one. Okay, let's see what we got here. This is problem number 67. All right, and there's a lot of words, but it's a little bit easier. So this is currently the Toyota Corolla is the best-selling car in the world. Suppose that during a test drive of 2 Corollas, one car travels 224 miles in the same time that the second car travels 175 miles. So if the speed of one car is 14 miles per hour faster than the speed of the second car, find the speed of both cars. So there was as I was reading this, I picked up on the distance between the two cars, and that the rate or the speed of one car is 14 miles per hour faster than the speed of the second car. Alright, so let's lay this out here. So we've got our distance equals the rate times the time. So this is not a motion problem because they don't talk about being against the wind or with the wind, anything like that. So my rate is just going to be my rate. The distance now we can lay out in these two cars. So what are we talking? We got the first car and the second car. You know, we'll label it as such. So here's the first car, here's the second car, and during that, suppose that during a test drive of 2 Corollas, one car travels 224 miles in the same time that the second car travels 175. So we'll call the one car the first car at 224, and the second car traveled 175. Okay, it's equal to, if the speed of one car is 14 miles per hour faster than the speed of the second car, what are these rates then going to be? So if the speed of one car is 14 miles per hour faster than the speed of the second car, so that must mean the second car is the rate is X, and the first car is going to be 14 miles per hour faster, which would give it X plus 14. A couple little discrete messages in there and how they're explaining this, which is which. But it found out to be that the speed of the second car, they're comparing. If the speed of one car is 14 miles per hour faster than the speed of the second car, and that told me that the speed of the second car was X. And look at the distance too, by the way. It's more on the first car than the second, so that's another little hint. All right, and then it's times the time, and that's what we're solving for here, where there's no mention of time, but I'm going to have that same equation of that t equals d divided by r when we're solving for time. That's ultimately what we end up doing here, right? So for the first car, that would be, I'll do it over here. The first car would be distance, this distance here, to 24, and it's divided by the rate, and the rate is x plus 14. Okay, and that's what r equals, given, I'm sorry, t equals. We're solving for t, not r. That's what t equals. And for the second car, it's going to be the same thing. That t equals the distance, 175, divided by the rate, which is just x. So t equals this, and t equals this. So now I'm going to put them together. And I'll do it this way. I just put do I want that? Yeah, equals, put them together, 175 divided by x. And that's what t equals. Okay, so this is gone now. I just moved it up here. And this is my proportion here. So I got 224 times x is 224x, and that's going to equal 175 times x plus 175 times 14. Let's see. So can I do that? Do it that way? Let's try it. I've got 175x plus, what's 175 times 14? Okay, where was I? 175, and then 175 times 14. I came up with 2450. Plus 2450. Alright, there's our equation. Alright, solve for x. So I'll subtract 175 x from both sides. And this right side here, I've got 9, 11 from 7 is 4, 49x. That's going to equal 2450. And then I'll divide both sides by 49. And x equals whatever this comes to. What was that? 175 and 14. Alright, here I could I have done it that way? Well, I'm not going to worry about it. Whatever it comes to, okay? How about I leave it like that? That would be what x is, and then I would take that answer. Hold on, I got to get my calculator. Okay, so that ends up, there's my work over here. I'm lazy to get my calculator. I don't know what's going on. So I got 2450 divided by 49 is 50, and that's what x equals, is 50. So we had to find the speed of both cars, or the rates. So the rates would be, the second car would be 50, and the first car would be 50 plus 50 plus 14, which is 64. So this was the second car, and this was the first car. And bingo, that's it. Alright, this one will make this is number 39. This is the last one I'm going to do for this video here. I think the others you can manage. They're similar to what we've done already or have done in class. We want to take this problem here. Suppose two trains leave Holbrook, Arizona at the same time, traveling in opposite directions. One train travels 10 miles per hour faster than the other. In 3.5 hours, the trains are 322 miles apart. Find the speed of each train. Okay, so when you have problems like this where they are buses or whatever vehicles that they're using, and they start at the same spot and they are going in opposite directions, with the detail that they're giving us here, that one train is, we've got the rate. We're solving for the rate. We've got the time and we've got the distance. But notice on here that we have one distance. So we've got that the time is the same and and the distance is the same as well. So when we have problems like this, then our strategy here is to not write down two equations, but we want one. So in essence, we're going to take something that totals the 322 miles, because it's kind of like if you're starting in the center and one train is going this way, another train is going this way, then what is it? In 3.5 hours, the trains are 322 miles apart. So then, from this point to this point, it's 322 miles. So we're kind of like, well, what are these rates here that they're going by? And what do we do to get to 322? What operation are we using? And in essence, we're adding them up. We're adding these two rates up that this train is moving in that given amount of time, which is the same time. So essentially, I could write this up as this is the distance between the two trains, and I'm going to add up the other components, meaning the rate and the time. Alright, so let's see what I've got here. I've got one train. Let's see. Okay, we got the leave Arizona. Doesn't matter where they're leaving from. It could be anywhere. Same time, traveling in opposite directions. One train travels 10 miles per hour faster than the other. So the other must be traveling how fast? The x. That rate of x. And then it's going to be multiplied. That rate is going to be multiplied to the time, which is 3.5 hours. All right, that's for one train, and then I'm going to add the second train to it, which is, what is the rate of the other train? Well, it said in here that one train travels 10 miles per hour faster than the other. Well, this is the other, so then the rate for the second train is that it travels 10 miles per hour faster. So that rate is going to be x plus 10. So that's the rate times the time of, same time, right? 3.5 hours. Now here's the rate of the slower train, or one train here, and the time, rate and time, and here's the rate and time of the second train. And we're going to add these up, get it equal to 322, because that's how many miles they traveled between them, going in opposite directions, given at different rates. Okay, so we're going to find the speed of each of the trains. And we're going to solve for x here. So let's do it. So I got x times 3.5 is 3.5x plus, this is distributive property, 3.5 times x here is 3.5x plus 3.5 times 10 is 35. That equals 322. Okay? Combine our like terms. I got 3.5x plus 3.5x is 7x plus 35. That equals 322. Subtract 35. Seven x equals, let's see, what is this? 12 from 5 is 7. Or 5 from 12, I should say. And then this is 11 from 3 is 8. Saying it backwards. I must be tired. And this is 2 brought down, 287. Okay, 287 divided by 7, so I'm going to divide both sides by 7. Okay, and what does that come to be? 7 into 28 is 40. 7 by 7 is 1, so it's 41. So the x equals 41. So what are the rates? Find the speed of each train. One train is 41 miles per hour, and the other is 41 plus 10, which is 51. For the other train. Well, that was that. Not bad. So review this a couple times when you're doing your own problem on your homework. It's basically the same, probably different numbers. All right, and I'm gonna let it go here. That's good enough. If you have any problems, you got these videos though too. But if you need help, you can give me a holler via email and see if we can get you through this. Okay? Alright, that's it. Adios. See you later.